Okay, can we start the lecture? In this semester, we are going to deal the power electronics
Hello,
subject.
sir.
Yes, yes, yes.
Screen is not visible.
Now,
Yes, sir.
now is it visible?
Yes, sir.
Okay, thank you. Okay, so we can start the power electronics subject. So before going to start the power electronics subject, okay, so we should know or we have to know some basics of the power electronics. Why we need to study the power electronics, clear? And why we are going for the concept of power electronics. Is it right? Okay, before going to the concept of start the syllabus power electronics. So we should know about the what is power electronic and why we are going for the power electronic and what is the necessary to study the power electronic subject. Is it clear? So before going to the topic also, we need to discuss some switches. Please. Okay, so in first unit we have some content. What is power electronic? Block diagram of power electronics. Clear? Next, advantages, disadvantages and applications of power electronics. Clear? Some semiconductor switches, symbols and ratings. Okay, construction of thyristor, or we can say switches and its classification, PN junction and so on, etc. Construction of thyristor, principle and operation of SCR, turn-on methods of SCR, static and dynamic characteristics of SCR, gate characteristics of SCR, triggering techniques of SCR, okay, protection of SCR, and specification and ratings of SCR. So here means from this content, what we can say, the first unit is totally based on the SCR. SCR means, I think you have studied in the diploma final year. Online students, can anyone give the reply? What is full form of SCR? Online students. Hello. Anyone, please?
Silicon controller rectifier.
Silicon
Controller rectifier.
control rectifier. Yes, nice answer. Thank you. So means in power electronic subject, silicon control rectifier is the heart of the power electronics. Okay. Yes, sir, is the heart of the power electronics. So I think you have studied in diploma about the diodes, MOSFET, IGBT and so on, etc. But I think you have not studied about the SCR. Is it right? SCR के बारे में कुछ पढ़ा है क्या डिप्लोमा में? फर्स्ट ईयर में तो नहीं है. फर्स्ट ईयर में तो नहीं ना? ओके. डिप्लोमा है क्या SCR का? नो. है क्या? सब्जेक्ट है. Okay. So here SCR is the heart of the power electronics. That's why we need to know about the SCR. What is SCR? How it will operate, and what are the characteristics of SCR? Okay, what are the turn-on methods of SCR, and what are the turn-off methods of SCR? Okay, how we can use in power electronic converters. Okay, how this SCR can be used in the power electronic converters. So all these things we should study in the first unit. So before going to start this subject, we need to study some switches. Why we need to study about the switches? Can anyone tell the answer? Offline. Why we need to study the switches? Because all the power electronic semiconductor devices are operated as a switches. Is it clear? This is the first and foremost important point. Please remember, all the power electronic semiconductor devices are operated as a switches. Power semiconductor devices कौन सी है? What are the power semiconductor devices? Diodes. Diode is also power semiconductor devices. Is it right? MOSFET is also power semiconductor devices. Transistors. Okay, transistor family means MOSFET, IGBT, BJT. Clear? And the thyristor family is also power semiconductor devices. Thyristor family means SCR. Okay, and some more devices are there, triad, diad, and we will see later. Clear? So means all these power semiconductor devices are operated as a switches. So switch कैसे operate होता है वो पहले मालूम होना चाहिए. Is it right? Okay, let's see the some switching operation. Any doubt, please, online students? Online students, please, regarding voice. Screen is visible?
Yes, sir.
क्या दिख रहा है स्क्रीन पे? Online students. Screen is not visible. Now?
No, sir.
Now?
No, sir.
Now is visible? Hello?
No.
No, sir.
Just wait. Okay, so all the power electronics semiconductor devices are operated as a switches. Clear? Okay, the electronic switches are generally called as solid state switches because there are no physical moving parts and hence absence of physical contacts. So why these switches are called as a solid state switches? Because generally we are having the switches on the switchboard. That is the moving part. Is it right? Moving part, hai na? And in some cases we are providing some switches to move the forward and backward. That is also movable switch. Is it clear? But these power semiconductor devices are operated as switches, and it is not these are not having any moving parts. These are not having any moving parts. For example, transformer can be called as a solid state device. Is it right? Transformer can be called as a solid state device. But in the case of electrical machine, can we call it as a solid state device? No, because it is a rotating part. It is a moving part. But transformer is not having any rotating part, or it is not having any moving part. So that's why the transformer can be called as a electrostatic device. Okay, or it is can also be called as solid state device. Is it right? So that's why same way here also, power semiconductor devices, okay, are called as the solid state switches because these are not having any rotating parts or any moving parts. Is it right? Okay, like mechanical switches में क्या होता है? Moving part रहता है. We can move the forward, backward. Okay, we can move the switch position 1, switch position 2. Okay, on and off and so on, etc. These are the mechanical switches. Okay, these mechanical switches are having the moving contacts or moving parts. But the power semiconductor devices are operated as switches, and it is not these are not having any moving parts. That's why these switches can be called as a solid state switches. Please remember this point, all of you. Clear? Okay, because why we are highlighting this point? By using these power electronic semiconductor devices, we are going to control the speed of the machines. We are going to control the speed of the machines. Clear? So whatever the techniques we are using by using the power semiconductor devices, that techniques can be called as a solid state control techniques. That techniques can be called as a solid state control technique. For example, we are having the speed control techniques. Armature resistance control method. Is it right? Okay, and field flux control method. Is it right? Do you remember speed control techniques of DC motors, armature resistance control method, and second one is the field flux control method, and third one is the armature voltage control technique. These three methods we are having to control the speed of the DC motors. Is it right? Okay, and one more method is there, that is the solid state control technique. Solid state control technique is nothing but the technique which is designed by using the power semiconductor devices. Okay, that techniques or that methods can be called as a solid state control technique. That's why I'm highlighting this point here. Okay, the power semiconductor devices are also called as a solid state devices. Is it right? This point is clear, all of you? Any doubt, online students? Online students, please. Hello.
Yes, sir.
Okay, so next point. Most of the appliances are controlled by semiconductor switches such as motor drives and HVAC equipments and etc. This point we have covered now. Clear? Because most of the appliances are controlled by semiconductor switches such as motor drives and HVAC equipments etc. For example, in home also we are having a single phase induction motor. घर पे single phase induction motor कहाँ पे रहता है? Can anyone tell? Offline students. घर पे फॉर एग्जांपल यहाँ पे किधर है? फैन पे. ओके, फैन पे सिंगल फेस इंडक्शन मोटर है. So to control the speed of that fan, so we need to design some control methods. Okay, we can use the power semiconductor devices in the regulator. Clear? We can use the power semiconductor devices in the regulator. By varying the voltage, the speed can be controlled. It is clear. So this is called as a one drive now. AC drive. Motor is AC. Supply is AC. Okay. So and we are controlling the speed of the fan using the power semiconductor devices. Is it clear? Next point. Okay. In power electronic circuits, the semiconductor devices are generally operated as switches either in the on state or off state. Switch means only two mode it can be operated, either be on state or either be off state. Is it right? Next, this is unlike the case in power amplifiers and linear regulators where the semiconductor devices operate in the linear mode. So see here one switch operation. Do you mean by what is meant by ideal? Ideal transformer means what? Okay, means ideal transformer means the efficiency of the transformer is 100% because we are neglecting the all the losses. Is it right? The transformer can be called as an ideal transformer. So like this same way here also, ideal switch. Ideal switch means same concept you can applicable here also. Ideal switch. Anyone? Ideal switches are those which can cause zero voltage drop during turn on and which can able to possess infinite current during this. Zero voltage drop. For example, switch is closed. Okay, switch is closed and the current is flowing through the circuit. Okay, from source to load. Is it right? When the switch is closed and the current is flowing from source to load, if any voltage drop is present across the switch, then what will happen? The power losses will be occur. For example, supply we have given the 230 volts and across the switch 20 volts are dropping. For example, 20 volts are dropping across the switch during the on period. And what will happen? 20 volts इधर ही drop आएगा तो वहाँ पे जितना voltage है उतना मिलेगा क्या? नहीं, because some amount of voltage is dropped across the switch. Clear? So some amount of voltage is dropped across the switch is nothing but there is a power losses is there. So that switch cannot be called as an ideal switch. But ideal switch किसको बोलते हैं अपन? The switch which is able to possess the maximum current during the on process, and the switch which can be handle the zero voltage when during the on process. Zero voltage drop. जब ऑन रहता है उसके अक्रॉस कुछ भी वोल्टेज लॉस नहीं होना चाहिए. क्लियर? Zero voltage drop, that is called as the zero voltage drop. Okay, and maximum current is flowing through that switch. Okay, that switch can be called as an ideal switch because no voltage drop means losses also zero. Losses also zero. So that type of switches can be called as an ideal switches. Clear? So obviously efficiency of that switches is 100%. Clear? So next point. Are you getting my point? Online students, please. Online students.
Yes, sir.
Okay. Next, ideal switch having three terminals like input, output, and control. Okay. So please listen. All the power semiconductor devices are having the three terminals or two terminals. For example, diode, it is having two terminals. For example, transistors, it is having three terminals. For example, SCR, it is having three terminals. So simply what we can say, all the devices are called as a switches. So simply we can say this switch is having the three ports. One is the input port, and second one is the output port, and third one is the controlling. Okay, the signal we are giving to the switch for controlling the output. Okay, that port can be called as a control port or control pin. Can be called as control port. Means simply we can say the power semiconductor switches is having the three ports: input, output, and control port. Clear? Like you can see here in this diagram. First port second port and third one. This is the control and this is the first port. We are giving the input. Okay, we are giving the input here. Always remember, we are giving the electrical supply as an input, maybe DC or maybe AC. Is it right? Okay, so means input is electrical supply, maybe single phase AC or three phase AC or DC supply. And when the switch is closed, the current is flowing through this circuit and the load is connected to the second terminal. It is clear? So when the switch is closed, the current is flowing through the load circuit. Okay, if we are designing any controlling circuit, so the signal is given to these switches. Accordingly, the power will be controlled. Okay, means voltage and current will be controlled, and this controlled voltage or controlled current or controlled power is given to the load. Then what will happen? The load is also operated accordingly. Are you getting my point? If the supply is 230 volts, okay, and output is only 100 volts we are getting. Okay, output is 100 volts we are getting. So accordingly, the load will be operated. Is it right? For example, in the case of DC motors, if you want to control the speed of the DC motors, we need to control the voltage. Is it right? We need to control the voltage because the speed is directly proportional to the voltage. Okay, we know the formula EB proportional to K into 5 into omega m. Back EMF is directly proportional to the motor speed, omega m. Omega m is nothing but motor speed in radians per second, or we can tell N. N is nothing but motor speed in rotations per minute. Clear? So means जब voltage control होगा तो क्या हो जाएगा? Back EMF control होगा. If the back EMF is controlled, then ultimately what will happen? It will be effect on the speed also because it is directly proportional. So whenever we are getting the 100 volts as output from the switch, okay, so ultimately the load is also operated accordingly. Clear? If the voltage is decreases, the speed is also decreases. If the voltage is decreases, the speed of the DC motor is also decreases. Is it right? So for that purpose, we are using the controlling port. It is clear how much voltage we require, how much power we require at the output side. Accordingly, we need to design the controlling circuit. Clear? So for that purpose, we are using the third pin, that is the controlling unit or control port. So here you can see, here we are having the switches. Switch 1 is the कौन सा पोजीशन में है? 1 ऑनलाइन स्टूडेंट्स, एनीवन? कौन सा पोजीशन में? ऑन मोड में है कि ऑफ मोड में है? यस प्लीज.
Off mode.
Off mode, yes, exactly. And second switch is
On mode.
On.
Please don't make noise. Yes, on mode mein. So here we need to discuss 2 points here. Always remember, it's a very, very important point. If this concept is not clear, so we cannot able to understand the power electronic circuit concept. अगर ये कॉन्सेप्ट समझ में नहीं आया तो आपको पावर इलेक्ट्रॉनिक कॉन्सेप्ट समझ में नहीं आएगा. क्लियर? सो क्या कॉन्सेप्ट अपन को डिस्कशन करना है यहाँ पे? When the switch is open, what about the voltage? When the switch is open, what about the voltage across the switch? No, I need one answer in 2 forms, 0 or maximum. When the switch is open, voltage is present across the switch. Across the switch, I am telling. Clear? This is the switch. Across the switch, यहाँ पे 10 आता है क्या? Yes, across the switch, maximum voltage is present. Is it right? कौन सा voltage present रहता है? Which voltage is present across the switch? Whatever we apply to the switch. अपन switch को input क्या दिया? अपन AC दिया क्या DC दिया? How much voltage we applied? For example, we have given the 100 volts single phase AC. So switch के across में 100 volts present रहेगा. Clear? If we are applied the 200 volts to the switch as an input, so on the switch is off position, then what will happen? 200 volts is present across the switch. Is it clear? So means what we can say here, when the switch is open, maximum amount of voltage is present across the switch. Clear? This is the first point. It is clear? Online students, please.
Yes, sir.
Sir.
Can you repeat the sentence? What I told? When the switch is off position, what about the voltage? You can get the question in the MCQ. If the switch is open, what about the voltage across the switch? You can get the question in oral examination also. You have a practical examination for this subject. Is it right? Okay, so external examiner can ask the question, if the switch is open, what about the voltage across the switch? Maximum. And next point, what about the current? Current is 0. Okay, so for example, if we are not having any way to reach the Pandharpur from college, so can we reach that place? अगर रास्ता नहीं जाने के लिए जा सकते क्या अपन? No, we will stop our journey. Same concept यहाँ पर भी है ना? Same concept here also. If the switch is not closed, how the current is flowing? So obviously the current is not flowing through the circuit. Okay. So ultimately what will happen? The switch is carrying the zero current. The switch is carrying the zero current. So here we need to remember 2 points. When the switch is open, voltage is present across the switch and current is 0. अगर आपने पॉजिटिव वोल्टेज अप्लाई किया है स्विच को तो पॉजिटिव वोल्टेज प्रेजेंट रहेगा. इफ यू अप्लाई द नेगेटिव वोल्टेज टू द स्विच, so negative voltage is present across the switch. This point is clear. And second point, the current is 0. I 0 and V is maximum. Clear? Next, exactly opposite to this switch. This switch is in closed position. Is it right? This second switch is closed position. So can you tell when the switch is closed, what about the voltage across the switch and what about the current through the switch? Voltage should be 0 and current will be flowing through that switch. That is the maximum. That is depends upon the load, whatever. Clear? So these 2 points we have to remember. If these 2 points are not clear, so we cannot study the power electronics subject. That's why today I have taken this topic. Before going to introduce the power electronics subject, so just I want to clear the concept of the switches, because all the power electronic semiconductor or all the power semiconductor devices are operated as a switches. Okay, so we need to check the characteristics of the SCR. We need to check the characteristics of the diode. We need to check the characteristics of the MOSFET. Is it right? Okay, when the SCR is turned on, what about the voltage and current across the load? ये तो चेक करना अपन को पावर इलेक्ट्रॉनिक में. अगर SCR क्लोज टर्न ऑन कंडीशन में है तो आउटपुट क्या मिलेगा अपन को? What about the voltage across the load and what about the current through the load? These 2 things we have to check in the power electronic concept. So for that purpose, we need to check the switch. We need to understand the concept of the switches. Already we have studied in the basic electrical engineering. Is it right? Okay, but again repeated this point. So next one, when the switch is open, it has 0 current through it and it can handle the infinite voltage. Already discussed this point. And next, when the switch is closed, it has 0 voltage across it and can carry the infinite current. Clear? Okay, this is the ideal switches. But while coming to the practical, so some little bit voltage to drop होते हैं ना. While coming to discuss the practical way, so little bit amount of voltage will be dropped across the switches, maybe 1 volt or 2 volts. That is depends upon the rating value of the switches. Okay, for example, if the switch is having the 230 volts rated value. Okay, if the switch is having the 230 volts rated value, so when the switch is turned on, So what we can say, zero voltage drop should be there, but little bit voltage will be dropped in practical switches. That is maybe 1 volt or 2 volts. 1 volt या 2 volt drop हो सकते हैं ना practical switches में. Clear? So ideal switches में simply we are considered as a zero voltage drop and zero voltage drop across the switch and maximum current through the switch. But in the case of practical switches, where some amount of little bit voltage will be dropped, that is depends upon the rating value of the device. Is it right? Characteristics person to person vary होते हैं ना. आपका characteristics मेरे characteristics different रहता है ना. Like the same way, the voltage drop is also depends upon the switches. That is depends upon the impedance. That is depends upon the rated voltage. It is having the it is depends upon the number of parameters. So simply what we can say, remember, some little bit amount of voltage will be dropped across the switch when the switch is closed for the practical switches. Clear? So let's see the characteristics are. Just wait, all of you. मैं जाने को चलो. Just 5 minutes. Just wait, please. Please. Just take one switches. Screen is visible?
Yes, sir.
Okay. This is the switch. Clear? So now, how we can draw the waveforms or switching characteristics? Vs V0. V0 means, or we can say, we can check the voltage across the switch. Clear? So what we can say here, voltage across the switch. Load के बाद में check करेंगे. Next. Current through the switch. Online students can repeat what is Vs. Online students, what is Vs and what is Is?
Switching voltage.
Okay, this is the VSW and this is the Vs. Vs means supply voltage. Clear? VSW means switch voltage. Okay. So, for example, the magnitude of the supply voltage is 100 volts. The magnitude of the supply voltage is 100 volts. नहीं दिख रहा है क्या? 100 दिख रहा है क्या? Okay, here I will write the magnitude of the supply voltage is 100 volts. Okay, so now here we can see, for example, this is the DC. The supply voltage is constant with a magnitude of 100. With a magnitude of 100. This is the 100. Clear? Next. So we can divide this some intervals. This operation can be divided into some intervals. For example, T1, T2, T3, T4. Clear? So, for example, if we will take the time in x-axis. Okay, maybe a seconds or whatever. So, if you would take the 20 seconds time on x-axis, so T1 is the 5 seconds, 10 second T2, T3 is the 15 seconds, and last one is 20 seconds. Okay, we have taken the 20 seconds operation. Next, this 20 seconds has been divided into 4 intervals, T1, T2, T3, T4, or we can say for each interval is for 5 seconds. Clear? So 0 to 5 seconds, initial condition 0 to 5 seconds, 0 to 5 seconds, the switch is turn on. The switch is turn on. If the switch is turned on, then what about the voltage across the switch and what about the current through the switch? 0 to 5 seconds में अपन को ये चीज दोनों कैरेक्टरिस्टिक्स ड्रा करना है. Can anyone tell? From 0 to 5 seconds, what about the voltage across the switch? First of all, check whether the voltage is present or not. 0 to 5 seconds में switch is closed. Switch is closed. Switch is closed. Is it right? If the switch is closed, what about the voltage across the switch? 0. Okay, the voltage across the switch is 0. This is the ideal switch. Means we are neglecting the voltage drop across the switches. Okay. Next, what about the current through the switch from 0 to 5 seconds? Maximum. Okay, so maximum current is flowing through the switch from 0 to 5 seconds. Is it right? Up to this point is clear? Last. Next, from 5 to 10 seconds. From 5 to 10 seconds, the switch is open. Switch is open. So then what about the voltage across the switch and current through the switch? Voltage across the switch is online students. Online, anyone can tell what about the voltage across the switch? Online, anyone please. Yes. Okay, voltage is maximum. Is it right? Switch off में, open position में, open means off. Off में क्या होता है? Voltage present रहता है. How much voltage is present across the switch? Whatever you applied the switch, 100 volts we have applied. Clear? So same amount of voltage is present across the switch, 100 volts. Is it right? Then what about the current through the switch? 0. Current through the switch is 0. Okay, and again the cycle is repeated or the operation is repeated. Again from 10 to 15 seconds. Again the switch is closed. जब switch close हुआ तो क्या हो जाएगा? Again the voltage across the switch is 0. Is it right? And the current through the switch is again increases. Clear? And when the switch is open again from 15 seconds to 20 seconds, what about the voltage across the switch? If the switch is closed, if the switch is open again from 15 second to 20 second, what about the voltage across the switch? Maximum. Okay, if the switch is open, current through the switch is 0. So can we draw the characteristic switches like this? Easy है क्या? Draw करने की easy है ना? Okay. Okay, these things we have discussed. Is it right? अब अपन जो discussion किया यही है ना? Clear? This is the switch voltage, red color, and this is the blue color indicates the switch current. From 0 to this point, 0 to this interval, the switch is off. The switch is off means maximum voltage is present. Maximum voltage is present and current through the switch is 0. And when the switch is closed, okay, when the switch is closed, voltage across the switch is 0 and maximum current is flowing through the switch. So like this way, we can easily draw the characteristics of the switches. Is it right? Clear? So simply they can ask the question, draw the VI characteristics of SCR. So draw the VI characteristics of diode. Okay, so we assume the two conditions. When the diode is on condition, what about the voltage across the diode and what about the current through the diode? And second condition, when the diode is non condition, what about the voltage across the diode, what about the current through the diode? So अगर ये दो concept है तो अपन we can easily draw the characteristics of the diode. Is it right? So like this way, we need to draw the characteristics of the power semiconductor devices like diode, thyristors, okay, that is SCRs, and also we can able to draw the characteristics of the transistors, triac, diac. Is it clear? So in first unit we need to check all the characteristics of the SCRs and operating modes of the SCRs, and how we can turn on the SCRs and how we can turn off the SCR. Okay, and then how this SCR is used in the power electronic converters. That will be discussed in the third unit, fourth unit, fifth unit, sixth unit, and so on, etc. This is the simple overall concept of the power electronics. Clear? So again, I will explain tomorrow switching characteristics of the practical switches. Today we have seen the ideal switch, and tomorrow we will discuss about the practical switches. Just small difference is there. Clear? So and then we will enter into the syllabus. We will discuss. We will give the introduction of the power electronics. What is power electronics? Why we are studying the power electronics? Okay, and what are the advantages of the power electronics? What are the drawbacks of the power electronics? Okay, and then we will discuss about the SCR. Is it clear? Is it okay, all of you online? Online students, please.
Yes, sir.
Yes, sir.
Are you understanding the concept of this power electronics?
Yes, sir.
Any doubt, please, you can discuss. Any doubt? Online students?
No, sir.
Okay. Thank you, all of you. Just wait, all of you, online students. Who is the CC of your class, third year, second semester?
Up, sir.